Hi everyone, my name is Stephen Poo, founder of the Terrestrial Project, and this is our Blockchain 101 series. So today we're going to talk about what types of data work really well with blockchain systems. So first of all, what does working well mean, right? So what does that mean when we say this works well, this data works well with blockchain systems? Well, typically we look at what types of guarantee blockchain systems are able to make on different types of data. So the first type of guarantee I think a lot of people start hearing about is this idea of veracity, right? So I think we've all heard that people call blockchain, the truth machine, the single source of truth, so that blockchain is able to tell what's true and what's not true, right? Well, this is actually very interesting, but blockchain is only really able to tell what's true and what's not true for data that was generated purely on the blockchain. Okay, so purely on the blockchain. So data that for example, is a coin. I have a coin. I'll transfer a coin to someone else. That type of data is purely generated on the blockchain, and blockchain systems are actually able to definitively tell you whether or not that data is true or not. Right. So very very interesting, very strong guarantee, but it only happens for data that's generated on chain. For data generated off chain, there is no such guarantee because there's just no way that blockchain will know whether or not something's true, right? So if I write something into the blockchain that says Steven just bought 2 watermelons from the supermarket, how is the blockchain able to tell whether or not that's true? There's just no way, right? Um, I can write whatever I want into it, and it will have no way of knowing it's true or not true, or what type of data it is, right? So veracity, number one guarantee, extremely strong, only guaranteed for on-chain generated data, not for off-chain generated data. Okay. Second one, provenance, where the data came from, right? So this provenance thing is actually also very, very interesting. Um, it tells you the source of information, right? And it does that through digital signatures. Now, it doesn't really matter if the entity that's generating the data is on chain or off chain, they all can leverage digital signatures, cryptographic signatures. So provenance can actually be guaranteed no matter where the data was generated, right? On chain or off chain. Okay. So the third one is what we call immutability. Well, immutability is also very, very fortunately, it can be guaranteed for any kind of data, whether it's generated on chain or off chain, right? Because whatever data that's stored on the blockchain is distributed across nodes, and everyone has a copy of it, and it's very difficult to corrupt or bribe a very significant number of those nodes, right? So immutability, you still have that guarantee for a well-designed system for both on-chain as well as off-chain data. Okay, so let's take a look at this. We keep talking about on-chain and off-chain data, right? So, I want to talk about the types of data, right? So let's first get an idea of how big these data sets are, right? So in this very unscientific quantification, right? So, if we're comparing the relative size of different types of data, we have on-chain data, which essentially is just a dot. It's like a tiny drop, right, in the ocean. There's just in the world of all data that's being generated, data generated on-chain is small, 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 and it's very insignificant, right? Then we look at data generated off-chain, right? We split into two types. Data generated off-chain, and that data is actually public knowledge, right? So what does that mean? What type of data is public knowledge? Well, what was the temperature yesterday in California, in Palo Alto, for example? Well, that's public knowledge, right? Who won the Super Bowl, right? That's public knowledge. So data generated off chain that is public knowledge. Well, that's significantly larger than the little tiny drop that's actually on chain data, but still, it's a very 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 small amount of data, right? Well, the vast majority of the data in the world generated off chain, and it's private data. But what does that mean? It's private data. It's not necessarily that it's secret. It's just that very few people know about it. Okay, so the vast majority of things in the world, information, is data that very few people know about. right? What did you eat for breakfast, right? You bought a car from Alice, and you got a raise, last month. I mean, this is all information that almost only really known to a very, very small group of people, and it's very difficult to validate, right? If you're outside that small circle. Okay, so on-chain data, tiny amount, right? So tiny amount of information is on-chain. Off-chain data is public, it's a little bit bigger, and the off-chain data that's private is the vast majority, right, of data in the world. Okay, great. So let's see what type of interesting guarantees that we can make. So we already said that on-chain data is great, veracity, provenance, immutability. All three guarantees. This is very, very good. This is why using blockchain systems as, for example, a currency is a great use case, because you can make all these strong guarantees, right? So great. But unfortunately, the amount of data that's generated on chain is tiny. So it only really covers a small, tiny aspect of our world. Okay. So then let's move into data that's generated off chain. Well, for data generated off-chain, we also said that you have both provenance and immutability guarantees, right? So you have guarantees here, so that's also done. So for off-chain, that's public, right? We said that the blockchain can't really tell, right, whether or not that's true, and that's right? It can't really tell, but there are ways to create mechanisms on the blockchain to create incentives so that entities and people and nodes don't lie, right? So for example, if the data is really publicly known, you could create data monitors, right? So if someone's committing a specific data, for example, the price of Microsoft stock, at exactly 5 a.m., yesterday, or the temperature in Palo Alto at exactly 5 a.m. yesterday, well, that's publicly known data, okay? So if someone commits false data into the blockchain, you can create mechanisms in which there are watchers that say, hey, by the way, this guy's lying. And these guys who are the watchers, they're incentivized to discover lies, right? So you can create mechanisms to, actually pretty well guarantee veracity, provided that the off-chain data is public. So it's sort of like 50-50 here, right? So it's not a native guarantee, but it's pretty good, right? So it's pretty good. Okay. Now, what you really run into trouble here is the vast majority of the world's data, right? There is absolutely no possible way that you can guarantee veracity. So no veracity guarantee. So on-chain data, we already talked about, very good, everything guaranteed, good, solved. But it's the tiny portion of the world's data. Off-chain data that's public, well, sort of also somewhat of a solved problem, but it's also, slightly bigger than the tiny bits of data that's on-chain, but still not that big, right? What about this? What about all the data, the rest of the data in the world, the vast majority of data, where you have no guarantee whatsoever on veracity? Blockchain does not know if it's true or not. So what can you do about it? You have these two guarantees, right? Provenance and immutability for the vast majority of the world's data. Does that give you anything? Well, actually, it actually does give you something, right? And this is a very unique insight that most people don't necessarily realize. It's that if you're actually able to guarantee the provenance of the data, you know exactly where it came from. It came from a person, it came from a device, it came from an organization, you know where it came from, the source. Guaranteed you know where it came from. Immutability, after the data was collected, it was not tampered with, it was not changed. These two things, what they guarantee is accountability, right? And accountability is a very powerful guarantee, okay? It's an extremely powerful guarantee because although the blockchain system doesn't know whether or not something is true, stakeholders who are privy to this information, they know what's true. right? And if someone's committing false data, off-chain, the stakeholders will be able to hold that person accountable, right? So if you're actually able to hold a committing entity accountable, the incentive to provide false data is drastically drops, right? So you actually now have an off-chain incentive system that is driving truthful commitments into the blockchain because the blockchain gives you provenance and immutability that enforces accountability. So this is a very, very, very interesting insight here. So although we cannot guarantee veracity, we can guarantee accountability. And in the end, that's actually really, really good, right? For the vast majority of the world's information. This really leads to the ability to build things like audit trails and audit logs that can actually add a lot of trust to information that otherwise are very difficult to collect and very difficult to verify. And the idea that we can drive and enforce accountability is really central to a lot of the applications that we actually build here at Terrassa, and that fully leverages these unique properties of blockchain decentralized systems. Thank you very much.